Nothing spices up a race like rain. And unlike your typical road tyres, Formula 1 and most track racing series use different types of tyres for wet and dry conditions. Why is this then? And how do wet tyres work? Well, let's look at what makes driving in the wet different. Firstly, remember that dry F1 tyres are slick. Now, weirdly, outside of racing, the word slick means slippery, but this is F1, and F1 never did try to make sense. Slick tyres are the grippiest tyres you can get. They're slick because they've got no tread at all in the tyre. The entire surface is smooth, flat rubber, noticeably different from your road tyres, which have to be ready for most typical weather conditions. The F1 tyres are slick because you want as much of the surface touching the track as possible. The grip is generated by the friction between the rubber and the road. More area in contact with the road means more grip. But when the track is wet, those slick tyres start to do the complete opposite of what you wanted them to do. And that's aquaplane. If there's enough water on the track, the tyres will start to ride on top of that water like a boat. A full aquaplane can lift the tyre completely off the track and give the driver no control at all over their speed or direction. Instead of maximising the contact between the tyre and the road, you've ended up completely minimising it. In fact, the floor of an F1 car is so low to the ground that if the track is wet enough, the entire car can sail down the track in a manner even Ellen MacArthur would struggle to control. The other thing to remember is that tyres grip best when they're warmed up. When cold, the rubber is hard and less grippy. Warming the tyres up makes them more malleable and sticky, gripping and hugging the tarmac, like an overly friendly aunt, I guess. So what do wet tyres do to overcome these issues? Firstly, the diameter of the tyres is larger. Not a lot larger, just 10mm or a centimetre, but enough to lift the floor up and away from the water and reduce the risk of full body aquaplaning. And then we come to the grooves. The grooves being the defining characteristic of the wet tyre. They cut channels into the surface of the tyre, leaving rubber islands between the grooves, known as tread. As the tyre turns on the wet track surface, the grooves channel the water, giving it somewhere else to go and allowing the tread to contact the road. The distinctive shaped grooves mostly aim to expel the water as quickly as possible away from the tyre, straight out of the sides. Wet, rainy conditions also cool the tyres down below that ideal malleable gripping temperature I mentioned a minute ago. Dividing the surface of the tyre into tread blocks also allows the rubber to flex a little more, which helps it to build up heat more quickly. Actually, the rubber on wet tyres is softer even than those on the softest dries, specifically to get them up to temperature much more quickly. You're probably aware there are two types of wet tyre in F1. The intermediates, which are suitable for most typical damp to wet conditions, and the extremes, the stronger soaker-uppers for when it gets really wet. There are a few key differences between both of them. Let's have a look at the tread patterns on each of the tyres. For a start, the tread on the inters is 3mm deep, while the extremes are 5mm deep. You'll notice the grooves on the inters don't actually completely divide the rubber into islands of tread. They displace the water in a much more passive way and have a lot more rubber on the tread, really maximising how much of the tyre still touches the road. Having more rubber surface will also stop overheating as the track dries up. The extremes, on the other hand, have a tread pattern that is heavily asymmetrical. That is, the outside of the tyre, the side facing away from the car, has a much more aggressive groove pattern than the inside. After all, when the track is drenched, you don't want to throw too much water at and under the car itself. The intermediate tyre can displace an amazing 25 litres of water a second, but the extremes displace a frankly ridiculous 65 litres of water every second. Every second! That's this many 2-litre bottles of your favourite brand of Diet Cola drink. No wonder it's basically impossible to see when following a car in the wet. So why don't we just use the wets in the dry and be ready for anything? Well, there's a number of really simple reasons for that. Firstly, in the dry, as said about 6 times already, we want to maximise how much rubber is in contact with the surface of the road for maximum grip. But this reason pales in comparison with just how quickly wet tyres degrade in the dry. I mentioned that a lot of the design of the wet tyres, the much softer rubber and the way the tread is cut, is to get the tyre heated up. I also mentioned that a warm tyre is much more malleable and sticky. Well, as with Chocolate Cake and the X-Men films, you can have too much of a good thing. Once the tyre gets too hot, it starts to degrade, crumbling to pieces instead of gripping on the track. This puts the lifespan of the tyre into extreme decline. As the track begins to dry and conditions are still marginal, you'll see drivers moving over onto the wet part of the track and away from the dry line to keep the tyres cooled down to a temperature where they don't start falling apart. Having said all that, Formula E uses one type of tyre for all weather conditions, so it's definitely possible. But Formula E aren't trying to maximise performance at every stage, so they're comfortable to go with the economical solution of using a one tyre for all. So there it is, that's how wet tyres work. Coming soon, I'll show you how drivers change their driving style and strategy in the wet, and what makes the difference between ending up drenched in dismal failure or soaked in success.